Hi everyone. We're looking at section 2.5, which is the last part of chapter 2, and this section is on interpreting graphs. So the beginning of the notes here are just having us summarize what we've talked about so far in this chapter. Remember what graphs are appropriate when you're working with numerical versus categorical data. So for numerical data, we had three types of graphs that we were working with that are appropriate to use. Do you remember what the three types were? We've got dot plots, was the first one we discussed. And then the next one was histograms. I'm going to abbreviate here. And then the last one was a stem plot or a stem and leaf plot. So those are the three that we're going to use anytime we're working with a numerical set of data. However, when we're looking at categorical data, we have different types of graphs we're going to use. And so our choices for categorical data, remember, are a bar graph and a pie chart. All right. So for each type of data, again, numerical versus categorical, we talked about different ways of looking at or analyzing the data. So for numerical data, there were three measurements we said we would use, and that would be the shape, the center, or the typical value, and the spread. For categorical data, there were two types of things we look at, or two things we use to analyze the graph, and that would be the mode, and actually I'm going to put the mode in the category next to the center because those are sort of analogous. And then the spread, or we don't call it spread when we talk about categorical, we say the variability. One thing we want to be aware of and be on the lookout for are graphs that are misleading, because that does come up from time to time, and we see that a lot, especially on social media and sometimes even in news reports. They'll use graphs that have characteristics that are misleading to make you think one thing or another. So well-designed graphs help us see patterns. See patterns. That's the word I'm looking for here. And then, misleading graphs, sorry, this is so short on space here. Misleading graphs may lead to incorrect conclusions. One thing you might want to look for is if a graph has inappropriate scaling. So one thing that might be misleading is inappropriate scaling. And if a graph starts at anything other than 0, that's a sign that they're trying to maybe get you to see something that's not really there. Another thing that you might notice is when they use icons of different sizes rather than using bars. Icons you want to try to avoid when you're making a graph. Sometimes they may look pretty or look fancy, but they can tend to make your eye see something that's not there. So that's why you want to stick to using bars instead of icons. Another thing to be on the lookout for, it's not necessarily a graphing issue, but be aware of vague research questions. So questions that are arbitrary or questions that could be a little bit subjective or maybe aren't clear, those kind of things you want to be on the lookout for as well. So let's look at an example here. This is from page 58 of our textbook, and it shows crime rates over a 5-year period. So what are the things that you notice about the graphs? Is there anything you think that might be different about the first graph versus the second? And hopefully you notice that in the first graph, it looks like it's a pretty dramatic drop in crime from the year 2007 to 2011. But what's going on with that first graph? Well, notice it doesn't start at 0, so it's scaled incorrectly. So the first graph does not start at 0. And the reason the author of this graph did that is because they want you to see that there's a more dramatic, or they want you to think there's a more dramatic rate or a drop in crime rates over that 5-year period. If we start the graph at 0, you can still see there's a decline. There's no question about that, but it's not quite as dramatic as it is in the first graph. So what is the aim of the first graph? To make it look more dramatic, to make it look like the drop in crime is more dramatic than it really is. All right, here's some other pictures. So take a look at these examples and see if there's anything you can say that's misleading about each graph. I would say each one has maybe a couple of things going on. Some things we've noticed, and I'm a little short on space here, so I'm just going to kind of talk through it, but some things we've noticed in the past about this first graph. Well, for one thing, the percentages don't add up to 100 for this pie chart, which is a little unusual. If you're looking at a pie chart, the percentages should add up to 100. Another thing that students have told me they've noticed about this graph before is that the wedges all look like they're about the same size. Remember that with a pie chart, the wedges should be proportional to whatever percentage they represent. So I'm not quite sure why these don't add up to 100%. One theory was perhaps that survey respondents were allowed to choose more than one answer. I'm not sure, but there's a few things there that are misleading. How about the second graph? It looks like we're looking at number of people receiving some form of welfare. Looks like this came from maybe a newspaper article. And hopefully you notice, well, first thing I think the eye notices is that this looks like there's a big increase in the number of people using welfare. However, I hope you notice right here, there's an issue. The graph doesn't start at 0. So again, the intent here is to make it look like there's been a larger increase in the number of people receiving welfare over this time period than there maybe really was. There was an increase, but maybe not quite as dramatically as the author of the graph would have you believe. And it's because the graph doesn't start, the vertical axis doesn't start at 0. The next picture, we're looking at, I'm not quite sure what the context was, but we're looking at banks and the market value at certain banks. And this graph is kind of all over the place. There's nothing on the horizontal axis, which I think is maybe problematic. There's nothing there telling me what's going on this way. I think the biggest issue though here is that they're using icons. And I think the point is to make the icons look like, you know, the people with the larger market shares have bigger icons, but it's hard to see a big difference. And so icons are really something you want to avoid when you're looking at a graph. It's just confusing and can really lead to some misleading conclusions. This last picture, it looks at gun deaths in Florida. And this is kind of a strange looking graph. They're talking about the Stand Your Ground law was passed in 2005. So they highlight that right here. But I hope one thing you notice about this graph is that the 0 is at the top and then the numbers are positive going this way. That's just a very strange way to draw any kind of a graph. When we think about a vertical axis or a y-axis, we start at 0 and then the numbers go up from there. So it's kind of a strange looking graph. You want to be consistent and you want to stick to good practices that we've used in algebra in terms of labeling axes and things like that. Let's take a look at the next example. It says, are private four-year schools better than public four-year schools? So why is this research question problematic? Well, I think the obvious answer is that better is a subjective term, right? What do we mean by the term better and how are we measuring that? Better is not a very, very concrete term. It's a very opinionated term. So I would say the research question is not a good research question to begin with. Then it goes on to say, suppose we use student to teacher ratio to measure the difference between private four-year schools and public four-year schools. So what is the data type? Well, if we're looking at a ratio, student to teacher ratio, that means we're dealing with some kind of number. And so this would be numerical. So we're going to work with numerical data. And you'll notice below that we've got histograms that represent the year 2010 to 2011 for 89 private colleges versus 49 public colleges. So what is the typical student to teacher faculty ratio for each data set? So we're looking for a typical or a center, if you will, for each one. So if you look at the first graph for the private colleges, somewhere maybe in here you can look at maybe the tallest bar, but you can give me a range. But I would say somewhere in here, maybe between 15 and 20 is probably what we would say for private schools. Let me go ahead and write that. So for private schools, actually let me write it up at the top here. So for private, the ratio, the typical value, I would say we can just give it a range. We can say 15 to 20. And then for public schools, if we use the tallest bar for the public schools, that would be here. So we could say the typical value for the student-teacher ratio at public schools is maybe 20 to 25. And you can give me a number. Again, this is a little subjective how we label the typical. You can give me a number. You could give me 22 if you want to, or you could say 20 to 25, really 20 to 24. Same thing with the privates. You could say 15 to 20, or you could say 15 to 17, or just 17. That would be okay too. Which graph appears to have less spread? So for less spread, I would say look at which graph has more values clustered together. So which graph has more values closer to the center? And hopefully you see that that would be the public colleges. There's more values that are in the center area, and then from there it really drops off. So we have some larger numbers over here and some smaller numbers over here, but more values are clustered near the center. Over here, the range from the lowest to the highest for both of them it's 0 to 60, but over here there's a little bit more of a taper. So we have more values further away from the center over here for the private colleges. So I would say less spread is going to be at the private, or the public school rather. So the public has less spread, and the reason we can say is that there are more values clustered, let's see, closer to the center area. So because we have more values further away from the center in the private schools, that means they have a larger spread. The next question says, what is the shape for each graph? So I would go back, let me make some space here. Let me erase some of this stuff so we can get a better look. So I would say that for the private colleges, there's more values below a certain cutoff point. So for the private, I would say there's more values below maybe 30. So I would say the private is probably a little bit more skewed right. The public, I would say, is a little bit more symmetric. You've got these clusters in the center, and then these tails are a little bit closer to even. So let's say that the private colleges, the graph is skewed right. So I would say that the private colleges, the graph is skewed right. And for the public colleges, I would say the graph is more symmetric. Let me go back to the picture again so we can kind of see that. So for the private colleges, we have more that are lower in ratios, and then it kind of tails off on the right. The public colleges, it's a little bit more symmetric. Finally, can you answer the question of interest? Well, which is better? Again, I think that's way too subjective of a question. So I would say no. We cannot answer the question of interest based on this information. Again, the question is problematic. Which is better is a hard thing to answer. So finally, at the end of the notes, I tend to do this for most of the chapters, I have a quick review that I want to go through that just sort of summarizes what we talked about in this chapter. So the first question says the following dot plot, just one dot plot, I guess, shows the number of siblings for a sample of 29 students. What percentage of students had more than 3 siblings? So make sure you're reading the question carefully. More than doesn't include 3, so we're looking at 4 or 6 siblings. So that means we had 2 out of 29. You can really leave it as a fraction. I'm really not too picky about how you write your answer, but they did ask for a percentage, and my math lab is going to certainly be a lot pickier than I will in terms of how you put your answer in. So this is about 0.07 or 7%. The next question says the following histograms show the distribution of monthly rents for a sample of studio apartments in 2 different cities. What is the shape of the distribution of rents for city B? So you'll notice for city B, you've got a lot of data here and then some over here, but then not a whole lot of data past that point. So I would say this graph is skewed, and I would say skewed right, because the tail, remember, indicates the direction of skewness. So because the majority of the data is under a certain amount, that means it tapers off and leaves us that tail on the right side. Part B says, which city has a higher typical rent for a studio apartment? So for city B, I would say you can probably look at this tallest column in your histogram, And it looks to me like that's the rent in that column would be somewhere between $1,000 and maybe $1,250. So maybe $1,000 to about $1,250 for the typical apartment there. Now for City A, you can see that the graph is, I would actually say this is maybe skewed left, you could argue. Most of the rents are above this number here. It looks to me like that number is about $1,750. So the typical rent there, I would say, is somewhere, I mean, you could even say $1,750 to $2,000. I would accept $2,000 to maybe $2,250. Either one of those would be acceptable, but either way, the typical value is certainly higher in City A, or the typical rent price is certainly higher in City A. All right, the next question. Data was collected on the ages of students at a community college. What shape would you expect the distribution of ages to have? We're talking about a community college, but even at a community college, really any college, the majority of students are going to be younger, probably in their 20s. Early 20s, mid 20s, maybe late 20s, even their 30s. You may have some older students at a community college, but either way, most students will be under a certain age. So think about if you were to graph that, if most students are under a certain age, that means you've got more data under an age, and then it's going to kind of taper off. So what shape would that be? That would be skewed right, or right skewed, because the majority of students are going to be under a certain age, say 30 or 35 or something like that. Number 4, which of the following is a graph that can be used to display categorical data? So remember, for categorical data, that would be a bar graph or a pie chart, and that's it. Number 5, which of the following cannot be used to summarize numerical data? So for numerical data, we would use a histogram, we would use a dot plot, but we would not use a pie chart. So the one that cannot be used is the pie chart. And then number 6, which of the following are used to describe the distribution of categorical data? Remember, we don't use shape with categorical data because there's no inherent order to it. We don't use center. Instead, we call it the mode, and that's the one we use for categorical data.